Okay, so in this video, we're going to be talking about how to simplify trig operations using things such as division, factoring, fractions, and multiplication. Okay, so let's look at how we're going to use this with division, right? So we've got tan squared over secant squared. So we can rewrite tangent as sine squared of x over cosine squared of x. And this is all over secant squared of x. Now remember, when we're dividing fractions, we keep the first and flip the second. So this is going to become sine squared of x over cosine squared x times the bottom flipped. Now I'm going to rewrite secant squared over here, which I should have done in the first step, as 1 over cosine squared x. So now I'm going to take this one and I'm going to flip it. So it's going to become cosine squared x over 1. My cosines will cancel, and I'm just going to be left with sine squared of x, right, over 1, which is just sine squared. So on the second, I'm going to go through my same process. So on the top, I've got cosine squared of x over 1 times sine squared x over cosine x. Oh, those aren't squared. I apologize. Sine of x over cosine of x. And then I've got all of that over sine of x. Notice that I have a cosine squared and a cosine in the bottom. So the cosine in the bottom on the top is going to go away. And this is just going to become cosine. So on the top, I have cosine times sine. And I have all of that over sine of x. Right, and I have a sine in the top and a sine in the bottom. So those are going to cancel, and we're going to be left with cosine of x. Okay. Again, if you have any questions about any of this stuff, please feel free to see me in class as well. Okay, so now let's look at the multiplication. Okay, so multiplying, we have to follow the steps of FOIL. So we're going to give everything to the other pieces. So we've got 1 times 1, which is 1. And then we've got 1 times sine, so 1 plus sine of theta. Okay, and then we've got, let me change the color to make it more obvious. So I did the 1 to both. And now I'm going to do the sine to both here. So I've got minus sine of theta, and then plus sine squared theta. Oh, I apologize. That's going to be a minus because a negative times a plus. A positive is a negative. Okay. So notice that we have a plus sign and a minus sign. Those two will cancel, and we're going to be left with 1 minus sine squared of theta. Now, 1 minus sine squared of theta, if you do recall, is one of our Pythagorean identities. So that's just going to equal cosine squared of theta. All right. Don't let beta over there confuse you. It's just another Greek letter. But you're still going to do the same process we did over here. So we're going to give cosecant to both, and we're going to give cotangent to both here. So we're going to have cosecant squared of beta, and then cosecant minus, or cosecant times a negative cotangent. So we're going to have negative cosecant beta cotangent beta. I'm going to do my second line below that because I can't fit it all. I'm going to change my color again. So here I've got a plus cotangent times cosecant, so I'm just going to rewrite it the same way I had it before. Cotangent times beta. And then we have negative cotangent times a positive cotangent, so we get a negative cotangent squared beta. Notice that our middle pieces there are going to cancel, and we're left with cosecant squared beta minus cotangent squared beta. Now, these again go back to our Pythagorean identities. I'm going to change cosecant squared beta to cotangent. So cosecant is going to be cotangent squared beta plus 1. And then we still have our minus cotangent squared beta. So the cotangents will cancel, and we're left with the answer of 1. Notice that we're still simplifying down to one term. Our answers will still always be one term here. Okay, so let's talk about what it's going to look like with fractions. Remember, when we're adding and subtracting fractions, they have to have the same base. So if we look at example 1 here, the bases look similar, but they're not exactly the same. We've got a 1 minus cosine and a 1 plus cosine. So in order to make the bases the same, okay, we're going to multiply by what's on the bottoms of the other one. So for our first fraction here, we're going to have 1 plus cosine of theta at the top. So I just took the bottom here and multiplied it by the top there. And my bottoms are going to be the two multiplied together. So 1 minus cosine theta and 1 plus cosine theta. And for the second fraction, we're going to take the bottom of the left one and multiply it by the top one. So 1 minus cosine theta. And then the bottom is going to be the same as the bottom of the other fraction. So 1 minus cosine theta times 1 plus cosine theta. Now that our fractions are the same, we can add the top and multiply out the bottom. So in the top, we're going to get 2 plus 2 cosine. Oh, that's a minus. Sorry, the cosines are going to cancel. So we're just going to get 2 in the top because cosine and negative cosine will cancel. And then in the bottom, we have to do the multiplication, so we're going to have to factor out. Now, I'm noticing that there's a minus and a positive, which means the middle terms are going to cancel out. So please keep that in mind. I would have gotten a plus cosine and a minus cosine, so I'm just going to skip that step. So on the bottom, I would have 1 minus cosine squared theta. And 1 minus cosine squared theta is a Pythagorean identity, so it's going to become sine squared theta. And we don't like to leave fractions, so the reciprocal of sine is going to be cosecant. So it's 2 cosecant squared theta is what we simplify down to. Again, you just have to take your times on these. Don't try to rush. Go one at a time. All right, looking at this one, we don't see any fractions yet, but we're going to create fractions because we're going to put everything in terms of sine and cosine. So secant here is 1 over cosine of theta. And then sine is just sine of theta over 1. And tangent is sine theta over cosine theta. Now we're almost there with fractions of the same base. We just got to multiply over here on the right. So we've got 1 cosine theta minus sine squared theta over cosine theta. Notice that the bottoms are now the same, so we can combine the tops. So we got 1 minus sine squared theta over cosine theta. 1 minus sine squared theta is a Pythagorean identity, so we're going to get cosine squared theta on the top and cosine theta on the bottom. There's 1 in the bottom and 2 in the top, so we're going to be left with just 1 cosine theta. Okay, again, just take your time and you guys can get to the answers. Okay, the last piece is factoring. So we didn't enjoy factoring too much when we were regular factoring, but now we're doing factoring with sines, cosines, tangents, and all those things. So please, please, please take your time. This is why factoring was important. So First step of factoring is always to take out a GCF. So if we look at the first one here, cosine is in common with both. So we're going to take out cosine squared. So cosine squared of x, and we're left with 1 minus sine squared x. Remember, I just divided both terms by cosine squared. Now on the right, 1 minus sine squared is indeed a Pythagorean identity. So cosine squared x times cosine squared x. So when we're multiplying powers, we just add them. So this is really just cosine to the power of 4x. Okay, so that one wasn't too bad. Okay, looking at the second one, we got to factor the top. You could factor the bottom, but it's actually going to be more beneficial to leave it. And we'll show you why. So the top has got powers of 4, but they factor just like powers of 2 would. So we factor the top, we're going to get sine squared x minus cosine squared x times sine squared x plus cosine squared x. And notice, this is why I said to keep them, that the sine squared x minus cosine squared x is also on the bottom. So we can cancel those two things out. So I can cancel the top with the bottom there, and I'll just be left with sine squared x plus cosine squared x. And sine squared x plus cosine squared x is indeed a Pythagorean identity, and so that answer is just going to be 1. Okay. So here are 2 practice problems that are at the bottom of that sheet. I want you guys to give that a shot. I'm going to put the work here so that you can check it out, and then if you have questions about where my work came from, please just come and see me in class. Okay, so for the first one, you should have gotten 1. Okay. And for the second one, there was a little bit more work, okay? The second one there, you end up getting cosecant of x. Oops. Okay, again, if you have any questions in those, feel free to see me in class. Okay, I take that back. I did not square my secant there, so my cosine down here should have been squared. So you end up actually getting cotangent of x, not cosecant of x. So it is cotangent of x. So if you need me to walk you through that, please stop by and let me know.